For this problem, we're again going to determine the domain of a rational function and try to determine any vertical, horizontal, or oblique asymptotes. Here our function is r of x equals x squared plus 2x minus 3 divided by x plus 1. We're again going to factor this, factor both the numerator and denominator. So we'll have r of x is equal to x plus 3 is x minus 1 divided by x plus 1. To determine the domain, recall that the domain of a rational function is all real numbers except where the denominator is 0. In this case, x equal to negative 1 makes the denominator 0. So our domain is a set of all real numbers for x such that x is not equal to negative 1. To determine the asymptotes, we'll start with vertical asymptotes. To find the vertical asymptotes, we look at our rational function in reduced form. This is already in reduced form. And so again, we look at the denominator. Any value for x that makes the denominator 0, but the numerator non-zero yields a vertical asymptote. In this case, that's x equal to negative 1. For horizontal asymptotes, we want to look at the degree of the numerator and denominator. The degree of the numerator is 2. The degree of the denominator is 1. Since the degree of the numerator is larger than the degree of the denominator, we will have no horizontal asymptotes. We do, however, notice that the degree of the numerator is exactly 1 more than the degree of the denominator. So that does mean we will have an oblique asymptote. To determine that, we actually have to do this division. And we can either do long division or we can use synthetic division because we're dividing by a linear expression. Go ahead and use synthetic division here. And then we're going to use c equals negative 1. We'll put in our coefficients, 1, 2, and negative 3. Drop down the 1, multiply and add, multiply and add. So we can see that our remainder is going to be negative 4. Our quotient here gives us our oblique asymptote. This is going to be x plus 1. So we have an oblique asymptote of y equal to x plus 1.